and welcome to Bubble Fest 2010. I'm Carolyn. Here at the Discovery Science Center, I am the resident bubbleologist. Today you're going to see some amazing feats of bubbleology, which means the science of bubbles. Everybody loves bubbles, and I'm here to tell you there's a lot of really cool science involved. First, let's think a little bit where we can find bubbles. These are all really good examples, and they all have one thing in common. That thing is water. Water is really important for bubbles. In fact, before we can understand the science of bubbles, we first need to understand the science of water, specifically one special thing called surface tension. Surface tension is just a fancy way of saying the tightness of the skin of water. That's right, water has skin just like you and me. And like our skin, it's on the outside. It's what holds the drops of water together. We can do some experiments to show this. First, let's use a strawberry basket with all of its holes and place it on top of a regular bucket of water. The basket floats. That's because each of the holes inside the basket has that surface tension holding it together. But if we poke it, the basket will sink. Another example we could try is using a jar of water with a mesh screen on top. It has holes just like that strawberry basket. If we flip it upside down and get rid of the card, the water will stay inside the jar because, like on the strawberry basket, in between each of those holes, the surface tension is binding it together. But if we disturb that tension again, the water will come out. Now, the last example for surface tension is one that you can try at home. All you'll need is a plate, a penny, and a water dropper. What you can do is see how many drops of water you can sit on top of the penny. So let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, and the water was able to fall off the penny. That's a fun experiment you can try at home to show that water has a surface tension. Now, if we add soap to that water, it will weaken water's surface tension, causing the surface to get stretchy. That whole surface is stretchy because of the soap. If we fill that surface with air, it can stretch even more and become a bubble. Now, that bubble will break or pop if we have something else that will puncture it, like a pen, or something dry, or even if they just sit out too long and become dry themselves. Now, what happens when our skin meets the skin of a bubble? Let's see. Maybe I should just blow the whole bubble. It pops. I wonder why. Maybe my hand is too dry. Let's see if that's it. I'll get my hand all nice and wet here, and hey, that worked out pretty well. Let's see if it works for a whole bubble. It lasted longer, but I don't think I'm gonna wanna get this sticky and wet every single time. Maybe I should try wearing gloves. A hockey glove. Let's see if this one works. Keeps popping. I don't think a hockey glove's gonna work for this. Maybe the lift yourself gloves. That one's popping too. How about gardening gloves? Well, the glove isn't going inside the bubble, but the bubble's bouncing. That's kind of fun. Well, these definitely are the best of the gloves. So, with all this water and soap, it's still pretty messy to play with these bubbles inside the house. That got me thinking, what if I made a dry bubble? First thing I thought of with talking about dry bubbles was this is dry ice. It's not like regular ice because it's not made out of water. Instead, it's made out of carbon dioxide, not water. Carbon dioxide is that same gas that we exhale. So if you were to blow out, we can't really see it very much because it's invisible. But if we get it cold, really, really cold, then we can turn it from a gas straight into a solid. How cold do we get it? 109 degrees below zero. And unlike regular ice, when dry ice warms up, it goes straight from being that solid to being a gas. It doesn't turn liquid, and it never becomes water. We call that sublimation. And since dry ice never becomes water, maybe it'll help us make some dry bubbles. Say hello to my Bubble-O-Matic. On this side, we have our dry ice inside of the bucket. The fog will travel up through the tube and out of the bubble blower. Usually dry ice takes a long time to turn into fog, so I'm gonna speed it up by adding some warm water. Now all we need is a little bubble solution and hopefully we can make some dry bubbles. These bubbles still seem a little bit wet. Maybe this isn't the answer I was looking for, but that's all right because I was able to use some imagination, some cool science to make this machine which made some really cool bubbles. Now if you think these bubbles are cool, just wait until you see what our special guest can do with bubbles. Enjoy the show, and don't forget to check out what all the other things you can do here at the Discovery Science Center.